All right. So today, guys, again, we're going to be going to the flow chart. And so I'm going to add some things to this. I've already labeled some exceptions that are not transition metals because today we're going to be talking about compounds that have transition metals. Okay. And so when we use the flow chart, we've been using compounds that have metals. So we've been going to the yes part. But then we've been using compounds that don't have transition metals. Okay. And so we've gone ahead and done one. We've talked about ionic bonds that just have two elements. Okay. So it was a metal and a non-metal. And then we've talked about compounds that had a metal with a polyatomic ion. All right. And so that's what you guys learned just previously. So now we're going to be talking about something that has a transition metal. So I just want you guys to look here. Nothing's really changing except for the metal. Okay, so for number one, it's going to be like 3A, except rather than a metal, we're going to have a transition metal with a non-metal. Okay, 3B is going to be like 2. It's going to be a metal polyatomic ion. Instead, it's going to be a transition metal with a polyatomic ion. And there's some different rules to it, but you have everything you need. Okay, so I'm going to go ahead and do some practice on number 1 and 2 real quick, just a quick review. Then we're going to go into 3A and 3B. Okay, so I have some examples that I want you guys to go ahead and write these down and just kind of follow along. Just to, if you're falling behind or you're not understanding, hopefully this review will help get you caught up. If it's not helping you, you need to send me an email. Okay, and then we can set up a Google Meet or a time to meet to talk about it. Okay, so number 1, so we're going to be doing rule 1 on the flow chart, and so I've gone ahead and labeled it rule 1. It's going to be 2 elements. It's going to be a metal and a non-metal. And how I know is because magnesium is a metal and chlorine is a non-metal. And I know because if I look at metals, magnesium falls under group 2, under a metal. Okay, and so you can see that it's highlighted. If I go to nonmetals, chlorine falls under those nonmetals. So I know it's a metal and a nonmetal. Okay, if that's the case, you have to just name the metal and then name the nonmetal, but add "ide" to the end. Okay, so when we have a formula, you're just naming. So once again, the rule is name the metal, which is magnesium. So it's going to be magnesium. And then normally you guys would want to put chlorine, but the rule states change the N to "ide." So it's magnesium chloride. Okay, so for rule 1, you're just naming the metal, and then you're changing the ending of the nonmetal. Now, when we are putting the name, okay, what I want is the chemical formula. All right, and so you have to remember the charges: group 1, group 2, 3, 4, 5, 6, 7, and 8. Okay, so you have to remember the oxidation numbers. So if I look, I have potassium, which is going to be a +1, and then I have sulfur, which is going to be a -2. Okay, and so just a quick little review. If you guys look on the periodic table, potassium's in group 1, which means it has 1 valence electron. That means it needs to lose 1 electron, and when you subtract a negative electron, it becomes +1. So just a quick review: group 1's +1, group 2's +2, group 3's +3, group 4 is positive or -4, group 5 is -3, -2, -1, and then obviously group 8 does not have a charge because it will not bond. They're already satisfied. Okay, so when we look at this, potassium's in group 1, so it's +1. Okay, sulfur's in group 6, so it's -2. It needs 2 to get to 8 valence electrons. Now, all you're doing is you're going to just switch the charges. They drop. Okay, so the 2 comes down to potassium and the 1 comes down to sulfur. Now, remember, you don't need to bring the negative and positive. All right, and so you're going to notice how these charges flip. So it's going to be K2, and it's going to be S. And technically it's 1, but because you write S, you have to have at least 1. So just remember you don't ever have to write the 1. Okay, so it's going to be K2S. And so that follows the rule for 2 elements. One's a metal, one's a nonmetal. Okay, now you guys just learned number 2. All right, and so you have a metal with a polyatomic ion. And how you can tell is you're going to have more than 3 elements. Okay, so if you look up here, I only have Mg and Cl. Even when I wrote the formula for potassium sulfide, I had potassium and sulfur, 2 elements. When there is a polyatomic, there is more than 2 elements. So if you look, I have calcium, oxygen, and hydrogen. That is telling me there's a polyatomic in here. Okay, so it follows the same rule. Okay, all you're going to do is name the metal just like we did for the binaries, and then name the polyatomic. This problem, we do not change the N to "ide." Okay, do not. Okay, so we're going to name the metal, and then we're going to name the polyatomic. And remember, I have given you all your polyatomics right here. Okay, so I'm going to look for OH. All right, so it's hydroxide. So it's going to be calcium hydroxide. So it's calcium hydroxide. All right, so all I did was I named the metal, and then I named the polyatomic ion. All right, now when I'm looking at a name, all right, the clue to usually figuring out that you have a polyatomic in the name, and I would write this down, is you're going to have an 8 or an ite at the end of it. Okay, so if you look on your polyatomics, you have acetate, carbonate, chlorate, chlorite, chromate, dichromate, okay, carbonate, okay, hypochlorite, nitrate, nitrite. So you can see there's a lot of 8s and ites. That's usually a key indicator that it's a polyatomic. Now, there are some that you guys just have to memorize that have ide. So hydroxide has ide, cyanide has ide, and ammonium is just one of those. It's the only positive polyatomic that you guys are going to be given. Okay, so it'll always come first. So those are 3 that you just kind of have to remember are polyatomics. You might mess up on them on a few times, but after you see them, after a few assignments, you guys usually pick up on it. Okay, so I have aluminum and chromate. Well, if I look at aluminum on the periodic table, aluminum is a metal and it's in group 3, so it's going to be a positive 3. Okay, so when I go ahead, it's going to be Al plus 3. And now I'm going to find chromate. And once again, you look on your polyatomic, chromate's right here. It's going to be CrO4 minus 2. So CrO4. And now what I'm going to have you guys do, put them in parentheses. And the reason being, it doesn't make it wrong, and it doesn't necessarily always make it right. But it just helps you to understand, don't ever change what's inside the parentheses. Okay, treat it as a one entity. Okay, so it's going to be CrO4, and I'm going to use its charge -2. Okay, now, just like we did up here, we switched the charges. Okay, the reason I have you guys put the parentheses is sometimes you guys will drop this 3, and then what you guys will do is you guys will give me CrO3, but you don't. Okay, that's not what it's telling you to do. Okay, but you are going to drop this, so go ahead and pay attention real quick. I'm going to move the +3 here, and then I'm going to move the 2 down here. Now watch how this 3 is handled, and I want you guys to see how chromate doesn't change, okay? So it's going to be Al, and that 2 dropped, so it's going to be Al2, and then once again, I'm going to put chromate in in parentheses, and now notice it didn't change, and I'm going to move this up just so you guys can see it. Now, the 3 is going to go outside the parentheses. Okay, so anytime you see a polyatomic, just put it in parentheses. It'll just help you guys navigate and make sure you guys aren't writing the wrong formulas. Okay, so some of you guys will give me CrO3 thinking that 3 changes to 4. It doesn't. Okay, so put your polyatomic in parentheses, put the 3 outside the parentheses. Okay, once again, now we're going to be going on to rule 3. Okay, you guys already know how to do polyatomics. Okay, you guys know how to name binary compounds. Now we're going to be going to transition metals. Okay, so is there a metal? The answer is yes. Is it a transition metal? And the answer is a yes. Okay, and how you know something's a transition metal is by looking at your periodic table, ptable.com. If you go under metals, there's a spot where it says transition metals. Go ahead and look. Okay, all of these follow this rule. There are 3 that don't, and I've given you the exception. Silver, cadmium, and zinc. These are exceptions. They do not follow the rule. You treat them as a normal metal. Okay, so I've gone ahead and added them. The exceptions that are not transition metals, okay, are silver, zinc, and cadmium, and I've gone ahead and given their relative charges with them. They never have a different charge, okay? Now, here's the thing. When you are using a transition metal, you are going to name the transition metal first, then you're going to determine the charge of the transition metal, and you're going to write it as a Roman numeral after the name, okay? And then once again, you name the nonmetal as an IDE, just like you would in 1. Okay, so 3A is going to follow 1. The only thing that's changing is the metal is now a transition metal. So I've gone ahead and given you guys an example. Okay, so we have cobalt and we have fluoride. Okay, so if we look, cobalt falls under a transition metal. Okay, fluorine is a nonmetal. Okay, so if we name this normally, this would just be cobalt fluoride. Okay, so you would write cobalt fluorine, but remember you changed the N to ide. Oh, I spelled fluoride wrong. Okay. Ooh. So messing it up. Okay, but the rule states I have to have a Roman numeral after cobalt. Okay, and so how do you find the Roman numeral? And so you can see down here, I've given you guys one that has the Roman numeral. This Roman numeral tells me the charge. Okay, and so if you guys look on your flow chart, I've given you the Roman numerals that you guys are going to be using. Okay, 1, 2, 3, 4, 5. All right, and so the hardest ones that you guys are going to be struggling with might be the ones that you are given the formula and you need to name it. Because what you have to do is you have to figure out the charge of cobalt. And how do we do that? Okay, and so what I'm going to go ahead and do is rewrite this. So you have cobalt and fluorine. Come on, quit giving me a period. Okay, and so I'm going to go ahead and just rewrite this, but I'm going to go ahead and space it just to give myself some space to write this. Okay, now you have to know the charges of this. All right, and so right now I technically only have 1 cobalt. Okay, and I have 3 fluorines. The problem is I know what the charge of fluorine is. Okay, and if I look at my periodic table, fluorine's in group 7, so it's a -1. So I have fluorine, which has a -1 charge. but I have 3 fluorines. So my total charge right now is -3. Okay, because I have 3 fluorines, each at a -1 charge. 3 times -1 is -3. Okay, now the problem is for something to bond, my charges have to equal. So cobalt needs a +3 charge. So how many cobalts do I have? Well, I have 1 cobalt. Well, what times 1 is going to give me a +3? Well, your answer is +3. Okay, so cobalt has a charge of +3. And because it has a charge of +3, that tells me my Roman numeral is going to be 3. So it's cobalt 3 fluoride. So the Roman numeral represents the charge. Okay. And so when you guys are given the chemical formula, you might struggle a little bit because you have to solve what the charge is so you can write it in the name. Okay. And so I've gone ahead and given you guys how to solve for the charge. Now, the other one is a little easier because I've already given you the Roman numeral. You just have to know, well, that's telling me the charge. So this is going to be manganese, not magnesium, Mn, and it is a transition metal because manganese falls under those transition metals, Mn. Okay. Now its Roman numeral is 2. And if you need to know how to find that out, I've given you the Roman numeral. Okay, so 2. So it's going to have a +2 charge. Okay, so remember, this is telling me my charge. Just like my charge told me my Roman numeral tells me my charge. And it already gives it to you. And now if I go ahead and compare it with oxygen, oxygen has a -2 charge. Reason being is because oxygen is in group 6. And everything in group 6 has a -2. So what I do is I'm going to go ahead and I'm going to switch my charges, just like I would on any other problem. Okay. So I'm going to get Mn2O2, and it can be reduced. Okay. So what you're going to have is you're going to have Mn2O2. But the problem is both of these can be reduced by 2. So it's going to be Mn1O1, which we know we don't have to write those ones. So it's just going to be MnO, magnesium oxide. All right. So if those numbers can reduce, always reduce them. Okay. Now, rule 3b on the flow chart. It's the same thing as 2, except rather than having a metal with a polyatomic, you're going to have a transition with a polyatomic. Okay, so you always name the transition metal, determine the charge, name the polyatomic ion. All right, so if I go ahead and look, nickel is a transition metal. It follows under my transition metals. Okay, but I also have SO4. So if you notice, I know there's a polyatomic because I have more than 2 elements. Okay, so SO4, if I look it up on my flow chart, SO4 is a sulfate. Okay, now how I would name this is going to be a nickel. And remember, I have to figure out my charge. So I don't know what the Roman numeral is. So it's going to be nickel something sulfate. Okay, and so just like we did it up here, okay, I have to figure out the overall charges for both my positives and my negatives. Okay, so if we look at nickel, I have 2 nickels. I have 2 nickels. And if I look at my sulfate, and remember, put them in parentheses so you know how many. Okay, I do not have 4 sulfates. Okay, that 4 is part of sulfate. So that's why I'm telling you guys to put the sulfate. And because there's no number outside the parentheses, I only have 1 sulfate. So I'm going to put the 1 just so you guys can visualize it. Okay. So I only have 1 sulfate. If you look up here, I would have 3 chromates because there's a 3 outside that parentheses. So I only have 1, or you have 1 is if you don't have a number outside those parentheses. Okay, because we don't have to write the 1. Now, I have to figure out what my total positive charge is and my total negative charge. Well, I'm always going to know my negative charge. Okay, I know the charge of sulfate. If I look on the polyatomic, the charge of sulfate is -2. So if I come back here, I'm going to write -2. So -2 times 1 is going to get me -2. So my total charge for my negatives in this compound is a -2. But now I need to figure out the charge of nickel. I have 2 nickels, so what times 2 is going to get me +2? And the answer is +1. +1 times 2 is going to get me +2. And the reason it has to be +2 is because I have a -2. It has to equal but be the opposite charge. They have to balance out. Okay, so because my nickel has a +1 charge, I now know my nickel needs to be a Roman numeral 1 because my charge for 1 is a Roman numeral 1. Okay, and we got that by finding what the charge of nickel is. Okay, so once again, now if I have the name, it's a lot easier to figure out because I already know the charge. Okay, it gives it to me in a Roman numeral. So if I go ahead and type this out, I have Cu, and it's going to be a +4. And how I know is because it gives me the Roman numeral for 4. And then I have nitrate. Okay, and the reason I know it's a polyatomic is because it has an 8. So I'm going to go down and look for nitrate on my polyatomic. It's NO3 minus 1. Okay, and so I'm going to put NO3, and again, put it in parentheses. Okay, just so you guys know not to change the polyatomic. Okay, and it has a charge of -1. And so I'm going to move these over just so I have some space to write these. I'm going to switch my charges. My -1 drops here. My +4 drops here. So what this actually becomes, it's going to be a Cu, and then it would be a Cu1, but I don't have to write 1. And then it's going to be NO3, and then that 4 is going to drop outside the parentheses. So it's going to be NO3, 4. Okay, and so this is going to be copper 4 nitrate. All right. So what you guys are going to be doing for Thursday and Friday is I've given you guys a list of compounds that have both transition metals and or polyatomic ions. Okay, and so when you guys are using your flow chart, you guys are probably going to be given 2, 3A, and 3B. Okay, so these are going to be the rules that you are going to follow. Okay, and so if you need to, resort back to the examples that I gave you. All right, if you guys have questions, please send me an email. Okay, I'd be glad to help you. If you have a question on certain ones, I can video record myself and send it to you. Odds are most of you guys might have questions on these. These aren't always the easiest. And so when you check your answers, and I will be posting an answer key, see what you did wrong. And if you're not understanding what you did wrong, send me an email. All right. Other than that, have a nice day, guys.